Welcome to Nearpod Lesson 4.8, the other trends in the periodic table. So these ones don't really relate to our ions test, but you kind of need to know them for chemistry. Didn't know quite where to put them, so I just kind of dumped them at the end. And here we are. So as always, a reminder to title your notes, what it says in the title. And the key idea you need to know from this video is to know the trend for mass and atomic radius, which is the size of the elements. Okay, so the first trend we need to know is the mass or weights of an atom. I highly recommend that you don't memorize anything because on your periodic table that I will allow you to use along with your notes, it literally says mass down here. It tells you that this bottom number is the mass. And then you're essentially just comparing the numbers, right? So if I asked you, like, which has a bigger mass, Cu, copper, or zinc, just look at the bottom number. Whichever one has the bigger number has the larger mass. Whichever one has a smaller number has the smaller mass, right? So just in case, though, in general, you should know that the mass of the period of elements, the mass of elements gets larger as you go to the bottom right hand corner. And the smallest mass is on the upper left hand corner. Again, please don't memorize this. It literally has the numbers on the periodic table. So, like, if you forget, just compare the numbers, right? So, like, oh, I can tell it's going bigger left to right, and I can tell it's going bigger going down, right? Okay. So the final trend you need to know is atomic radius, right? So definitely know that atomic radius is just the size of an element, right? How big it is. So definitely know that the trend of atomic size or atomic radius gets bigger as you go down. This makes sense, right? Because every single time you go down a period, the atom increases a ring of electrons. So here I have one ring of electrons in period one. In period two, or row two, I have two rings. Period three has three rings, so on and so forth. But on the other hand, you also need to know that atomic size decreases the further you go to the right. Right? So I kind of find this image confusing. Basically, here's how I would write it. As usual, I would do the outline of the periodic table. Like that. And then down at the bottom left is my largest radius. And on the upper right hand side is my smallest radius or my smallest atom, right? So going from top to bottom getting bigger makes sense. But if you double check your periodic table, notice that as you go from left to right, let's look at row two here. Here I have 3 protons, 4, 5, 6, 7, 8, 9, 10. My number of protons, or the stuff that makes up my atoms, is actually getting bigger going from left to right. So if I'm having more stuff on the periodic table, you might be wondering, wait, why is it going smaller from left to right then? That doesn't really make sense. So let me explain why that is. So here I've drawn out lithium, this element over here, but a simplified version. And over here I have neon. So this one that's a little bit bigger, or it should be smaller on the other side, right? So basically what's happening is if you think about magnets again, I have a positive charge and a negative charge. Now, this positive charge is kind of small, and this positive charge is way bigger. So even though neon has more stuff and it weighs more, its magneticness is greater. So what ends up happening is that rather than it being this size, right, the positive charge is pulling in tightly all these electrons so that it ends up being smaller just because this positive charge is greater, right? And because this positive charge for the protons is weaker, it can't pull in those outer electrons as well, making them slightly wider, right? So to note this, basically saying that as we increase the number of protons, we're pulling the electrons closer to the center, right? So this has more protons, it's pulling the electrons closer to the center, making the size of the atom smaller, or the size of the atom is less wide, even though the ones over here kind of weigh more. They're just kind of like super cut and built, right? These ones are kind of like foofy, and they're a little lighter, a little wider. All right, so on to some practice problems. So given the elements listed below, which elements will have the largest mass? So hint, use your tinyurl.com/Quan P table. So I'm going to compare bismuth, aluminum, and oxygen. So what I'm going to do is go onto this P table and find bismuth, aluminum, and oxygen. So aluminum is here, oxygen is here, bismuth is here. So again, since the question is asking about which one has the largest mass, remember that on your periodic table, the mass is just that bottom number. So comparing all these bottom numbers, bismuth weighs 208.98 compared to a puny 26.98 and 16. Bismuth has the largest mass. It has the biggest number, right? So therefore, bismuth will have the largest mass. This is my answer. Okay, so let's try another problem. Given the elements listed below, which elements will have the largest radius? Right, so I'm going to need my periodic table again, and I'm going to need to remember that elements have a larger radius as I go down, right? And elements get larger as I go further to the left. So first I'm going to look for hydrogen, lithium, and sodium. Let's check it out here. So let's choose a different color. Hydrogen, lithium, and sodium. Look at that, all lined up. So they're like here, here, and here. So which one has the largest radius? Well, remember my radius gets bigger as I go down. So the one furthest to the bottom, sodium, Na, will have the largest radius, right? And that's pretty much it. So those are all of the patterns on the periodic table. You can go ahead and try the next couple of practice problems on your Nearpod after this.